Alright, hello everybody. This is the lesson for 6.4. It's actually a pretty quick lesson. But all we're talking about in this lesson is on rectangles. Alright, and things we can learn about rectangles. Now, what we're starting with is, let me back up. Remember, all chapter 6 so far is dealing with different types of quadrilaterals, and what we've been dealing with a lot lately, parallelograms. Right? And rectangles are just, all rectangles are parallelograms. Alright, so we're kind of talking about parallelograms, and then specifically in this lesson we're talking about rectangles, right, and properties we know. So what we're starting with is properties of rectangles. They share the same as properties as parallelograms. So all four of these properties we ended up writing down in 6.2. They apply as well for rectangles. Alright, and then we are going to be learning about a few other things that we can learn from rectangles. So, first problem we have is it says quadrilateral MNOP is a billboard in the shape of a rectangle. Alright, and then it says MO equals 6x plus 4, and then PN equals 7x minus 4. Let's take a second, maybe pause this and copy that down. So, what we have is we have a rectangle, and one thing we know about rectangles is diagonals are the same. Right? You did not write that down earlier, but that's one of the main facts that we know about rectangles. It's different than parallelograms. The diagonals are always equal to each other, or as we say, they're congruent. Alright, so if we know this is a rectangle, that means these two diagonals are congruent to each other. So that means I'm just going to set these two expressions equal to each other and then solve for x. So if we subtracted 6x from both sides, we would get x on this side. Add 4 to both sides, and we would figure out x equals 8. Alright, so if we knew that that billboard was a rectangle, we would know that x would have to equal 8. Alright, then moving on here. We're going to skip that one. Next, it says Kyle is building a barn for his horse. He measures the diagonals of the door opening to make sure they bisect each other and they are congruent. How does he know that the measure of each corner is 90 degrees? So this Kyle guy is building a door like this, and he measures the diagonals. And and then he makes sure that they bisect each other and they are congruent. And then the question is, how does he know that each corner is 90 degrees? Well, two properties of rectangles in particular is if you have two diagonals that are congruent to each other and they bisect each other, that means this and this are the same, and this are the same. Those two properties apply for this quadrilateral. That means it has to be a rectangle. And if you have a rectangle, that means those angles have to be 90 degrees. So I'm going to say if diagonals are congruent and bisect each other, angles have to be 90 degrees. The reasoning, that's just properties of a rectangle. Alright, so let me pause that there if you didn't write all that down. Sorry for my handwriting, but that's just rolling with it. Alright, moving on. Next we have our last thing. Told you it was a quick lesson here. This problem takes a little bit here. So it's quadrilateral FGHJ has vertices that determine whether it is a rectangle or not. Alright, so this is kind of a loaded question. First thing we're going to do, we're going to write in those vertices. So that is F. G is -2, -5. Like that. H is 4, -2. Then J is 2, 2. There we go. Alright, so that would be our rectangle. What we have to do, we have to figure out if it is a rectangle or not. Alright, and two things have to pass in order for it to be a rectangle. One, we're just going to be paying attention to the diagonals. So, two things have to exist. If the diagonals are congruent to each other, and if they bisect each other, that proves that the quadrilateral is a rectangle. And let me give you an example of each one. So if we have, so this is what's called a trapezoid. Sometimes trapezoids have the same, diagonals are the same. Alright, if you look at that, we could say those diagonals are congruent, but obviously that is not a rectangle. So that's why we need to show both sides that they bisect each other. Right? And like if we were to look at a parallelogram like we have in the past, sometimes parallelograms bisect each other. Alright, in that case that is not a parallelogram, so it doesn't look like it. But if you were to draw a parallelogram, one of the properties of parallelograms, the diagonals bisect each other. Alright, so if both of those tests kind of pass, then that means it has to be a rectangle. Alright, so we have to prove those diagonals are the same and that they also bisect each other. Alright, so we got to prove both. So first, we're just going to first try and prove if these two diagonals are congruent to each other. So how to do that is you just got to use distance formula, and I know most of you don't like doing distance formula, but it's something we need to do. So first, I'm going to find the distance of FH. Alright, so I have my two coordinates here, F and H. So distance formula, remember, I'm just going to write it real quick here. X2 minus X1 squared plus Y2 minus 1 squared, and the square root of all that. Alright, so to find FH, we would go 4 minus a negative 4 squared plus Y2 minus Y1. Alright, 4 minus negative 4 is 4 plus 4, which is 8. 8 squared will give us 64. 2 minus a negative 1 is negative 2 minus negative 1 is negative 2 plus 1, which is 1. 1 squared is just 1. Alright, so FH will give us a square root of 65. Alright, and then next I'm going to find what's the square root of GJ. Sorry, not square root, the distance between GJ. Alright, so to do that, we would go X2 minus X1 plus Y2 minus Y1. 2 minus negative 2 will give us 4. 4 squared is 16. And then 2 minus negative 5 gives you 2 plus 5, which is 7. 7 squared is 49. Alright, and 16 plus 49 will give us 65. So, GJ and FH are both 65. Alright, so that proves that those diagonals are congruent to each other. Alright, but remember, we gotta have both of those tests pass in order for it to be a rectangle. So what we're going to do next is we're going to look at these and figure out what's the midpoint, and then we can just figure out if they bisect each other or not. Alright, so one way we can do that is if we look at F and H. We can find the midpoint of that, which if you just added up the two x's together and divided by 2, you would get 0 divided by 2. So the midpoint, I'm just going to write here, 0. And then if you added up negative 1 and negative 2, you would get negative 3. Negative 3 divided by 2 gives you negative 1.5. Alright, so that's the midpoint. Next, what we have to do, we got to find the distance between that midpoint and F. Alright, I know this gets to be a loaded question, but I'm going to write my two coordinates here, negative 4, negative 1. I'll just do this real quick. X2 minus X1 gives you 4 squared plus Y2 minus Y1, which is just 0.5 squared, which ends up giving 16.25, square root of 16.25. Alright, I know I'm kind of going through this fast, but I feel like we should be able to figure this out. Then we have 4, negative 2. Then we gotta find the distance to that. 4 minus 0 will give us 4 squared, plus y2 minus y1. Negative 2 minus a negative 1.5 will give us a negative 0.5 squared. And we end up getting 16.25 square root of that. Alright, what does that tell us? That tells us that both of those distances are the same. So what did we just prove? We just proved that those diagonals are not only congruent to each other, but they also bisect each other. Alright, because we just proved that those two sides that I just highlighted there are congruent. Alright, so I know that was a long problem, but it was a good example of you. Alright, thanks for listening. That was 6.4. It's our second to last lesson of this chapter. Alright, thanks. Peace.